everyone, today we are reviewing the topic Uncertainty in Measurements, Unit 2, Module 2. The topic will proceed as follows, where we will look at questions and their answers. The teacher will discuss certain aspects of the topic, but we may not go into detail on every aspect under the topic Uncertainty in Measurements, just the important details. So let's proceed by stating what is uncertainty in measurements. It is said that any measurement made by an operator, has some sort of error, and this error is referred to as experimental error. Experimental error can affect accuracy or precision or both of these aspects. It is said that there is experimental error in any measurement because the true value of a quantity cannot be measured at every instance most accurately and with the highest precision. In any experiment, there must be an established true or accepted value. For example, in a titration, it's usually 25.00 cm cube. If you're asked to weigh out 10 grams of a solid, the true and accepted value would be that 10 grams. As said before, with any measurement, there is going to be some sort of experimental error. And let's look at our definition of experimental error. It is said to be the difference between a measured value, that is, the difference between a measurement and the true value. Now, this difference is expressed as a quantity referred to as uncertainty. Experimental error is said to affect the accuracy and/or precision, where accuracy is defined as the closeness of this measurement or measured value to our true or accepted value. And precision is defined as the closeness of the measurements, that is our measured values, or the spread of these measured values around a central value. Now keep in mind here that precision looks at the spread of values around a central value which may or may not be a true or accepted value. At the Unit 2 level, you should be able to look at a series of experimental values and be able to state whether the values are accurate or precise or not accurate or not precise. So let's take a look at these spread of experimental values represented as darts hitting a dartboard, where the center of the dartboard will be our true or accepted value. So in looking at the spread of the values we have here, we are looking for ones which are accurate, meaning how close are the measured values to the true or accepted value. So I'm looking at experiment 1, 2, 3, and 4. So if our measured values were accurate, this means they should be close to the true or accepted value. So between experiment 2 and 3, 2 is accurate and 3 is also accurate, but we can say it's more accurate than experiment 2. But both are accurate, which is fine. Let's talk about low accuracy. We would say that in experiments 1 and 4, because the measured values are far away from the true or accepted values, experiment 1 and 4 would be inaccurate or not accurate. Now let's look at the precision of the experimental values obtained. We would say that an experiment has a high precision, or it's precise, where the measurements are close to each other. So that means, what can we say about experiments 1, 2, 3, and 4? In 1 and 2, the values seem to be far apart, so both experiments would have a low precision, and in experiment 3 and 4, the values are close together, so these two experiments would be precise. So let's look at our values once more. In the first dartboard here, we would say that the values are not close to the true or accepted value, therefore it is not accurate. There's a high spread, that is, there isn't a lot of closeness between our values, so it is not precise. In experiment 2, our values center around our true or accepted value, therefore it is accurate, but there's a bit of a spread or a lack of closeness between the individual measurements, so we would say it is not precise. In experiment 3, the values are very close to the true or accepted value, therefore it is accurate, and there is a low spread or a closeness of the individual measurements, therefore it is precise. And in experiment 4, our values are far away from the true and accepted value. Therefore, we would say it is not accurate, but because the values are close together, they are precise. With a better understanding of why in an experiment accuracy and precision can be affected, we will move on to looking at what errors or experimental errors can affect accuracy and precision. The two types of errors we will look at are called systematic or determinate errors, and the second will be random or indeterminate errors.